We have two types, performance and resilience. Let me actually talk about performance and resilience right now. So it's kind of another uh, performance and resilience are different in one very big way. Here we always go for how fast things are going for us, how fast the server can respond. Um, is it slow and fast? So most of the questions will be answered in terms of the speed or the processing power of the system, or anything that we are trying to test. In resilience, we are gonna talk mainly about failures and problems. So if you want to break the system, before production, then these kind of tests will be useful, because ultimately the system is gonna break at some point. It's always good if you can break it before production, so or before the real use case. And in resilience, we actually try to break and bring it back from the dead. So it's not just about breaking the system. If, for example, a couple of nodes die or one availability zone is dead, can you bring it up to the same level without interrupting services? Or if you are interrupting them, then you need to interrupt them for as little as possible. Also, in terms of failures, it shouldn't. We need to keep imagining new ways to make sure that the user is not impacted. I mean, if one of the node goes down or the database goes down, we shouldn't have. With the database, probably we should have problems, but um, there shouldn't be repeated transactions, copied the same transaction multiple times, or missing transactions. So user sends some transactions and there is no record of it anywhere, which is really strange thing. Um, these kind of things. So yeah, performance and resilience. And let me talk about them one by one a little bit more. So what performance testing covers is, as I mentioned, the speed, the how fast things can go. Um, and how fast they should be going based on the SLAs or whatever agreements you have with the customer. And um, we can classify them, or at least I classify them like this. So sometimes, or most of the times, we begin with benchmarks. Benchmarks are something like a measure of how fast the system will go if you repeat the request that usually the client sends. I classify them in two more parts, which is focused and comprehensive. So, for example, your system can process four requests at four different protocols, or if it's a website, it can process 100 checkouts per second. But usually, the checkouts don't come without the people navigating to it. But still, if you want to build a test for the checkouts, you can just somehow get to the step of checkout directly on the website and try to do 100 checkouts per second. It will be focused benchmark because you are focusing on one type of request. You are just doing the checkouts. Comprehensive would be when you perform the whole user journey. For example, you click on the home page, then you click on the product, search for a product, or search and click, and those kind of things back and forth, and do it a little bit more randomly. Then you go to the checkout page, and the whole journey you repeat it with 1000 users. That will be a comprehensive test because you are comprehensively doing multiple type of requests. In another type of a system which works on, for example, is a file transfer system where you can send files via different protocols. For example, I work with a system which was able to send on FTP, SFTP, HTTP, PSIT, and so many different kinds of protocols. So building some tests with just one protocol, just send and upload and download files on SSH, for example, and upload and download files on all of them together would be comprehensive benchmark. So these two have this one has a benefit that it's easier to debug, but it's a bit different. It's a bit far from the reality. So uh, sometimes, or quite a few times, you will not catch issues like when the system has to process tens of different things at the same time. It might hit issues that it's never gonna hit um, when uh, sorry, I think I did say something wrong. When you are doing the same type of request, it's easier to debug, but you are not gonna get you are not gonna find the issue that you will find with multiple different types of requests in when you're trying to do the comprehensive benchmarks. So yeah, it's a bit more hard to debug. But again, if possible, try to do the comprehensive ones, because when you find an issue with this one, it's most likely that it will be reproducible and it will be there in the production when the things go live. The next one is scalability test. Here again, the focus is on performance. We are not trying to break and bring the dead back. We just need to see if, for example, in the diagram that I showed to you, if I increase the number of nodes, these ones, and I make go from 2 to 3, or let's say I have just one in one use case and then I add a second one, then how much processing power is added to the system? Does it actually go 2 times the processing power, or does it like usually when you double the nodes or the processing systems, it doesn't become 2 times, because there is overhead in syncing these servers and talking to file system and database. But even if you get a decent upgrade, it's not going to double for sure. But if you get close to double, that would also be really, really great. That means your other parts of the system which are common are not breaking it up. Also, the synchronization between these nodes is not very time consuming process. Those kind of things. So in scalability, we have two types: vertical and horizontal. So vertical scalability is when just a second. Horizontal is when we add the servers, because I always confuse between the two, but I know that concept. So if you add more nodes, that's horizontal scalability. For example, if this is a AWS EC2 instance and this is another AWS EC2 instance, and if you add more and more EC2 instances, that would be horizontal scalability, where you are trying to scale by adding more individual servers or individual processing nodes. Vertical scalability is when you add more processing power to this node. So you increase the CPU from 2 CPUs to 4 CPU. That would be vertical. And you increase the RAM from 4 gigs to 10 gigs. You increase things like that on this then you are doing vertical. And both type of tests might be needed at different times to make sure that you can meet the SLAs. You can achieve what you're trying to achieve. Spike tests. So in this one, the only difference is the load model. So here, this more looks like a spike test to me. On the left, just point it, it's the, let's say, the load or the request per second, and here it is the time. So if you have a 30-minute test and you go for 10 minutes and you in the middle of the test, it's still not very spiky. So let me make more. It's like a spike now when you are going more than double of your load, or yeah, pretty much like where you have in the evenings got lots of users, or when you have a sale live on a website, or when suddenly all the stores are closing and they are trying to upload all their data at the end of the day. It's a spike, and it's interesting to see how much what will be the performance of the system at at that point of time. So um, we need to meet the SLAs at pretty much the whole time. In most of the cases, response time should still be lower here, and that's what we need to test in spikes. Again, not trying to break it or not trying to send it through the roof to see if things are breaking, but in a, let's say, in a controlled manner, increase the load and measure the performances, and don't still not trying to break it. That's how I categorize them. Let's go to the resilience test. This is exactly how it looks like in the picture. Let's break stuff and see if things break. Are we still gonna do what is the right thing to be done? So if you are in an airplane and one of the engine goes down, the plane is supposed to keep flying and not pretty much not come down, because usually there are two engines. But you don't want to do it directly in the air. You want to do it when the plane somehow test it when the yeah in simulators or things like that. Um, This is the resilience. What is an endurance test? When you run the endurance, or sometimes I used to call it longevity test, is when you put the system to longer tests. So usually benchmarks are half an hour, 15 minutes, 1 hour, depending upon how much you, how like how repeatable, how much repeatability you want to build. But if you have a test which is going on for 2 days or 3 days, or depending upon um, your judgment, what will be the correct duration for your system, you can build a longer duration test. It doesn't necessarily need to go as fast as possible. It could go at a medium pace or double the usual load. And you have to observe, in this case, the leaks, and the response times are not so important here because you're already having benchmarks for that. Um, but yeah, again, if you feel, if you are interested, feel free to observe the response times and how fast the system is during the time. But most critical thing is there any leaks after 3 days? Try to monitor the heap memory, or the memories that the system uses, and see if there is a something is consistently going up. Usually if it's going up and it's significant, then the system will fail after some time. In your analysis, try to look for the whole entire duration and not just the averages. So um, try to look what happened in the first hour of the test, first day and the second day and the third day. How many transactions were processed on the day one? How many transactions were processed on the day three? Is it slowing down? Things like that. It comes in endurance test. Idle test is similar to endurance. I mean, is related to endurance, but just opposite of endurance, where we don't perform anything on the system. Just leave it idle for some time and observe if the system scales down, if it's an automatically scaling system. Again, sometimes the systems are just hungry for transactions, and when they don't find it, they start behaving strangely. For example, I worked with an application where it was uh, uh, trying to pull a directory for new files, and once it didn't find the file, it still put some kind of a event in the queue that the processing was done, and in the end the queue was full anyways, and the system came down after some time, and we actually found that issue. Another good point to do the idle test is to see if the system scales down, of course. So the resources should be minimum if it's an automatically scaling system. Under stress test, we increase the load to the point where we think the system would break, and pretty much keep increasing it until the system breaks. This is for the analysis that actually when the system breaks, how it breaks, and you can actually report really nicely to everyone that this is the breaking point of the system, and that gives you a little bit more confidence that okay, this is the breaking point. Then most probably, if I am going at this pace, I'm still far from the breaking point, and usually we should be far from the breaking point. What is a failover test? If one node in your system fails, for example, here, if this node fails, this is kind of a user of the node, must be redirected to another node. Um, in this case, I have not put a load balancer here, but usually in the middle there is a load balancer. This test executor will send the request to the load balancer, and this will also send the request to the load balancer. In one of the node, if fails, then all the requests should be redirected to different nodes. The reason I didn't put a load balancer here, because most of the time load balancers are used third party, and they are not the things that we are trying to test. We are trying to test something that we built. So but yeah, if you have a your own load balancer, then you should definitely send it to the load balancer and see how things are going to go. But pretty much whatever transactions are being processed by one node should be taken up by node 2 without any loss, repetition, or uh, corruption of the transactions. And again, if it's in your SLA that no matter if a couple of nodes goes down, the performance will be observed, then you should definitely also take a look at the performance. The last one is recovery. So all systems go down eventually, as you know. Any hardware will go down at some point. Any server that you use, if you leave it for tens of years, at some point it's gonna fail and crash. Or yeah, I mean that's kind of theory that I think about. But maybe in 10 years you will change your server. But anyways, If it goes down, how fast can it come back? So after that, you have to spin up another node. When it spins up, you have to check that the traffic is again systematically is synchronously, or not the word, symmetrically distributed between them. uh, when the node is coming up, if it some transactions are sent to the node, how what it does with those transactions. So uh, if I mean the node could come up in stages, and it shouldn't misfire some of the transactions just because it's coming up. It's these are tricky things to do, but at least you know where you are going in the right direction, and by the complexity of it, you can judge that you need to be very organized and careful in your approach when you are trying to build a solution like this, because if you don't have a way to check the transaction, say, so when you build your first test, you definitely need a way um, to make sure that the transaction that you actually sent was processed properly. There are no duplicate transactions. You should have checks on the uh, for example, other side of the test. If you are sending things to database, it's always great to, if you can somehow check in the database table if the right number of rows are created for each transaction, things like that. Those kind of checks are really critical when you build your test. Otherwise, in the end, you won't be able to see how many transactions were actually live. So again, try to be organized in the approach as much as possible. Otherwise, it's gonna get messy real quickly. Um, that's about how I visualize performance and resilience tests, and that's why the topic of the lecture is performance and resilience and not performance testing, because both of these things are really important.